Okay, you should have reminded me. Okay, then these ones are gone already. Okay, but that's fine. Now the next question is, how do you superimpose the graph? Superimpose the line. What do you do? Let's move on. Now, in that case, what you have to do is that you take 2 points, right? So let's go here. What are some of the points? We can take 5. If we take 5, x is equal to 5, y is equal to what? Please compute it and tell me. If x is equal to 5, y is equal to what? Okay. But I can take x is equal to 0, y is equal to 2.4. So somewhere here.
It
Then
is
I
minus
take
5.1.
it's what?
Minus 5.1.
Minus
5.1.
5.1.
Yes, if x is equal to 5.
5. Okay.
Yeah.
So in that case, we don't really have what? What is it? You cannot get a cost. Then it's like you are actually incurring a loss. A loss. So it wasn't a good one because of the way I chose the.
It is what negative 72.6 if x is equal to 5.
Yeah, so we want to get something. So let's say when x is equal to 1, we have something like
2.4
yeah, 1
minus
point
2.
something and so forth. So it will be somewhere here, not a good graph.
So is it 1 point negative 1.5 or 15x?
No, I mean when x is equal to 1, we have what?
0.9.
0.9. So let's say somewhere here. So if we are to join with the line, we to be something like that. Okay, which is not good for, because I did not compute it, if you remember. I just hazard any guess, and then we moved on. Okay. But assuming it was plus, then we would have gotten 2.4, and then plus this we would have gotten what, like 7.5, around 10. So it would be 5, and let's say somewhere here. And then we join them with a line like that. So that's how you superimpose the line on the graph. Is everybody okay with this?
Okay.
Good. Okay. Any question? Yes, you raise up your hand. Please ask your question.
Equal to 2.4 plus 1.5x. Why didn't you add the random error?
Oh, the random error, once we find, that's what we use in fitting the least squares principle. Right? So once you estimate your equation, there's no random part. That's why in SHS, you wouldn't have understood all those randomness. So what they gave you is actually y cap ms plus c. But they don't really add this one. So you just have what? Y is equal to ms plus c. This is deterministic. That's why I wrote deterministic. So as soon as we do this, we know what y is giving x. Yeah, so you won't have the error part. The error part is assumed to be normally distributed with mean 0 and variance sigma squared. So one of the values, okay, if you remember when I did, I said that in simple linear regression, sorry, 1x plus epsilon. So your epsilon is what? 0 sigma squared. So actually in 222, you will also be estimating this one, sigma squared. So once you're able to estimate that sigma squared, it gives you what? A complete description of your line. Okay.
Oh, okay.
All right.
Thank you.
Next. Any question? Okay.
Yes, sir.
Yes.
Please, about the derivation of the formulas.
Yes.
Please, I tried to use the normal differentiation to do it, but it seems I was not getting the formulas.
Then you are not arranging them properly.
And besides, why did you divide them by the beta naught and the beta 1?
Why did I divide?
Yes, and set it equal to 0.
Okay. This one I should be asking you that. But
Yes, I know.
you know.
The problem is, why did you divide it by the beta naught and the...
I'm not dividing. That's a differentiation. The objective there is to find, remember we set it to 0, right? So what are we finding?
Yes.
We are finding, remember we said the minimum, SSE. We said that the principle is that you want to find beta naught minus beta 1 x squared. What this and that will minimize this error. Minimize. And what is minimization of a function? In mathematics, you use or calculus, right?
Differentiation. Yeah.
Good. So that's why we were doing differentiation. Yeah. That's it. Okay.
Sir,
Yes.
please, why did we square the difference? Why didn't, could we have used
Do you remember why you squared the variance? In 111 when we were finding the variance? Were you in my class?
No, sir.
No. Okay, because I usually will talk about this. Who can help us? At least those who were in my class. Can we get one person to explain why we square SSE? Let's start with S. What will happen if I do this? If I define S as this, can you tell me what this will be equal to?
It will be equal to 0.
It will be equal to 0.
Yes, 0.
Why? To be equal to 0, they are right. So what it means is that if I have these values 3, 3, 3, 3, and 3, and then I have 1, 2, 3, 4, 5, right? If this is X, this is Y. Each of them will give me 0. Each of them will give me 0. But are they the same? No. You can try this at home, okay? Yeah, so there's then an ambiguity as to when you get your deviations to be equal to 0, you wouldn't know whether it is the values are the same or they are not the same. Okay, but as soon as I start squaring, what happens? What will be this one? Will it be equal to 0?
No.
No.
Will S minus S bar squared be equal to 0?
No.
Really?
Yes. Yes.
Why?
Oh, yeah, yes.
Yes, yes.
Good. Okay. What about this one?
No.
Would that be equal to 0?
No.
Why?
Because the numbers are different.
The numbers are different. Yeah. So the reason why we do this in statistics is mainly this problem. So when I do this, you know, all this, if I were to do Y minus Y bar, Y bar, not cap, I'm going to get a negative, because the mean here is 3, right? So I'll get -2, -1, 0, 1, and 2. So if I add them, I get 0. But if I square, what happens? Oh, what is happening?
If you square it, all the negative numbers turn to positive. So then
And
it won't
then,
be 0 again.
oh, and unfortunately, I can't see my screen again.
Yeah, same here. We can't also see.
Share whiteboard. Existing whiteboard. Oh,
Sir, please, I've
hey.
made you the host.
Yeah, but I can't see my whiteboard again where I was writing December 29, December. Oh, a recent. Okay, let's see. Oh, what happened?
I more online class.
Okay, just let me.
So it's just because the hook was straight, like it was straight up. It was straight to Clifford, not you. That's why the board went off. So
What?
unless you restart, I said you won't be able to get a whiteboard again. Hello?
Oh, okay, let's see. New existing whiteboards, it's not really new whiteboard. Ah. Okay, there we are back. Good. Okay, so yeah, so that's the reason why. Because if I
Sir,
have
please, I
this,
can't help. Sir, please, I can't see any whiteboard.
you can't see the whiteboard.
I still can't see the whiteboard. No.
So you can't see.
Oh,
The same here, copy.
can you see now? Oh, I have gone to another.
Yeah, now you can
Yeah,
see,
yeah.
but
You can see,
Yes, I
you can
not that
see
bad.
now.
Yeah, right. Don't worry. Can you see now?
Yes.
Good. Okay.
that's it.
So it's the same concept. Okay, if you have this and you draw your line, the arrows, I talked about this, from here to here and so forth. If you subtract them and you add, it will give you zeros. Okay, so then it will be ambiguous. We wouldn't know whether all the points are on the line or they are scattered around the line. So it's the same concept we did in 111 that we are applying in this setting. So I hope this answers your question. Okay, good. So now we know how to compute beta not beta 1, right? How to interpret them. What if we want to do what we call forecasting? So 2.4 plus, let's say, 1.5x. So we say, what is the average? What is the average cost if mileage is, let's say, 10 kilometers? Oh, 10 miles. We were using miles. So that's what we called what? Predictions.
It will be 17.4.
It will be what? So you will say y cap will
17.4.
be equal to 2.4 plus. I have changed this to plus because the minus doesn't really make sense, right? Okay. So you get
Yeah.
on 17.4. You have to add the
Cost.
million
Mouse.
Ghana
The million.
cities, something like that. Okay. It's important that you do so. So that's the average cost for a 10 miles road. Okay. Any question on this? Okay, next is that we need to find what we call coefficient of what?
Determination.
Coefficient of determination. And how do we find that? I said we call it R squared, and it is nothing more than your what? Pearson's correlation. Is that okay? So how
Yes,
do
sir.
you find the Pearson's product moment correlation? R is what? N sigma xy minus what? Sigma x, sigma y. Then we'll divide by what? The square root of what? N sigma s squared minus what? Sigma x all squared. And then what? N sigma y squared minus sigma y all squared. Isn't it? Like this. So your R squared is nothing more than what? The top squared. And then the rest you divide by that. Can you quickly find that? For the values we did provide. So let's see how it is. Let's do that together. Please be quick. Somebody should find sigma A, somebody sigma Y, and then you call it. And then we move on. We don't have time. Quickly. We have 5, right? N is 5. What is sigma SY? Quickly. Other than that, sigma
236.
SY is what?
236.
236.
6. Okay. Somebody should provide sigma X.
45.
45.
45. Sigma Y.
32.
Okay. Sorry, this should be squared, right? Then N, this is 5. Sigma S squared.
571.
577.
7177. Which one? Can somebody confirm? Can we get somebody to confirm that one?
71.
577.
577. What about sigma Y squared? Somebody should do sigma Y squared. Somebody should provide sigma Y. Sigma Y is what?
Sigma Y 32.
Sigma Y is 32. Okay, so 32 squared. What about sigma Y squared? What about sigma Y squared? Somebody now should do the top, the numerator. Somebody should also do the denominator. Then we provide, then we give the answer, and then we move on. Please, what is sigma Y squared?
282.
What?
282.
282.
Yes.
Good, okay. And this is equal to what? Either you give me the entire answer or something else.
And the top one is 67600.
And then now, I want the actual value. So if you are finished, just give me, then we move on.
The next week downstairs, but same it comes. That's what I mean.
You, when people are calculating, you are there talking. Please, what is the value? Otherwise, let me choose something, then we move on.
Say, hold on. No, we are coming.
All this while, I say somebody should compute the top. This, that you are not doing it.
331960.
331960. And it is equal to what?
That's the down one.
Okay,
Yeah.
no, I mean the entire, the R square will be equal to what?
2, 6, 7.
It's what?
6, 7. Bye.
0.2036.
0.2036.
0.20.
36.
Good. 0.20 is okay. So
Okay.
what can you say about this?
So there is a weak correlation between.
Hey, look at this one. This is not correlation.
Strong.
It's not correlation.
One.
We said this is what?
Regression.
Hey, it's not regression. I just wrote this back.
Coefficient of determination.
Coefficient of determination.
Yes. And what does it measure?
Just the rank.
It measures what?
The rank.
The what?
Oh. The rank.
Rank.
Rank. Yes.
Really?
I think this one we multiply it by 100 to know the percentage.
Okay, so we multiply it to be what? 20%. How do you interpret it?
Please is 20% away from the variance.
20%?
From the total variance.
20% of the variation.
It differs 20
One person,
from the variance.
please. One person. Yes.
We can say 20% in variation in cost.
Yes.
Is explained by regression on merit.
Good.
Yes.
Yeah. So 20% of the variation in the cost of the project or the road construction is explained by what? The regression of our cost on mileage. That's how they should be interpreted. Is everybody okay?
No.
Please come again.
No, sir. Please, we don't understand.
You and who?
I don't understand.
I also don't understand.
Somebody just explain. You say we.
Okay. Come to us.
Me too.
Come to us.
What we are saying is that 20%, remember you did, please, keep quiet and listen. You did, I think with these values, I don't know. We did not even compute the beta naught and beta 1. So I'm assuming this is the, so we've done this regression. This regression is about what? Cost and what? Mile. So what this is saying is that 20% of the variation in the cost is explained by this regression on miles. So which means 80% is not explained by just the miles, right? It may be to other instances. Let's say the nature of the road, the nature of the terrain, and so forth. Is everybody okay now? Is everybody okay? Okay, then we can move on.
Yes.
Let's move on because we have to close now. Now, before then, you remember I wrote this, right? What is this one?
So I can't see your screen.
You can't see the screen.
Yes.
Some of us can see. So maybe.
Yeah, I think you must unjoin or something like that. Unjoin and join. Okay. So what is happening is that if you track back, so please track back and give me the correlation coefficient. If you are tracking back, it means this will no more be there, right? To get this one, okay, so that you give me the correlation. If you have the coefficient of determination, you can't really tell us the correlation because
0.447.
is it positive or negative?
Positive.
It's positive.
Yes.
Okay. So R, which is equal to n sigma xy minus sigma x sigma y divided by n sigma x squared minus sigma x all squared. Okay. And sigma y squared minus sigma y all squared is equal to what? You said 0 point what?
No, it's negative. It's not 0.
Okay, because the values we gave, I was surprised that you were telling me that it's positive. It is what?
Negative 0.2036.
2036. Are you sure?
But say our coefficient of determination is 0.2. So the root.
Yeah, 20. It was this one now.
Hey, there's a difference. Do you understand what I'm doing? There were two things. This is correlation coefficient.
Just joined.
Okay, this is what? Coefficient of what?
Determination.
Determination.
Say.
Yes.
But you told us if we square our correlation, we get our coefficient of determination.
Yes, but vice versa is difficult unless you know the sign of the beta. Okay, so that's why I said check, but it will not be this if what you provided me was right. Okay, it's okay. I am assuming it is this. Please calculate it on your own.
So, but if we square this, will we get 0.
So you won't get that.
We won't get it.
Yes. So find it. Don't be arguing. You are arguing. What is the value? Okay, but essentially it won't be this, right? But let's move on and say that this is our correlation. Okay. Now, the question is, can we say that this correlation is significant?
No.
Can we conclude that this is significant? I'd say 5% significance level. You see, once we do this, we are talking about what? Hypothesis testing. Is everybody okay? The fact that we computed this and it is what? Negative 0.3. Has somebody found the actual value?
Yes, sir.
What is it?
Negative 0.45.
Negative 0.45. Okay. So let me clear it. Negative 0.45.
45.
Oh. 0.45. Okay, so something like that. Okay. So can we say that this one in level 100, we'll say that there is this or some moderate negative correlation between what? Cost and what? Mileage. What it means is that as the miles increases, we expect cost to decrease. This is against what we know, right? So that's why I said the data was just conjured, in class. So it may not really represent what? Reality. Now, the question is, can we say that this is statistically significant? Okay. Now, to do so, we have to do what we've been doing as what? Hypothesis testing. Which means you need your hypothesis, you need your test statistics, you need your critical region, you need the decision and conclusion. Is everybody okay? So the question is, how do we do this? Well, we will state our hypothesis. So the hypothesis here will be that we have rho. Remember, the correlation coefficient is rho, the population parameter is 0. Right? Then remember that our H1, we can have basically 3. We can have not equal to 0, greater than 0, or what? Less than 0. Do you remember this?
Yes.
Same concept. Yeah, so the
Sure.
alternative. Then we come to our test what? Statistic. What is our test statistic? Well, here we have a T. And that T will just be the R we compute from tables. Sorry, from what we just did. Right? Like this. So our T is like this. Then we say that under H naught, T is what? T with what? N minus 2 degrees of freedom. I hope everybody is okay with this. Then the next thing we do, so that was 1, 2. The next thing we do is the critical region. What is our critical region? Well, it depends. So 3, our critical region. Remember,